How to upload this without the iPad, so because I gotta do it on my phone, and I've already started this video like 4 times and it keeps going blurry and I don't know why. So I'm just gonna start with some helpful hints on your homework. 13, 14, and 15, you're supposed to find the points of inflection, so you gotta find second derivative. So like for that second derivative, don't forget chain rule, or chains, wrong one, sorry, product rule. First one times the derivative of the second plus second one times the derivative of the first. So your first derivative should look like that. And then the second derivative, you do it again, and you should get that. And then you might be like, well, how do I solve that? Well, you factor it. Factor out the e to the x, set each factor equal to 0. That's all I have to say about that. Second one should get ugly. It's product rule and chain rule. First one times the derivative of the second. Or it looks like on mine I did the second one times the derivative of the first. And you get this first derivative, you get this big nasty thing. You can simplify that to this. So then when you do your second derivative, you gotta do the derivative of that, and then you gotta do quotient rule. Then it does get ugly. It gets big and ugly. Figure it out. And then 15, I think is also kind of ugly. I don't know, first derivative, it's just the ones you have to have memorized. Second derivative, then you could either do a negative power, like there, or do quotient rule. It's up to you. That one should be the most doable. But then the solving for 0 part might be bad. Yeah, anyway. So here's the part I was going to add for today, the graphing. So this is going to be 21, 22, 23, and 24. They give you graphs, and just based on the graphs you have to answer some questions. Like 21 and 22 says, use the graph to determine where f prime and f double prime are 0, positive, and negative. So I've already set it up. I'm going to figure out where f prime is 0, where it's positive, and where it's negative. I'm also going to do the same for f double prime, 0, where it's positive, and where it's negative. So the important thing on these is to remember what you're looking at. For this first one, we know the graph we're looking at is the graph of our original function, and we're going to figure out where all of these things happen. So it's pretty simple. The easiest thing to find is when slope. Remember, derivatives are rate of change, or slope. So, and I'm sorry this thing keeps going blurry than clear. I don't know why it happens. This will be hopefully quick. So slope is 0. Where does that happen? Well, that's easy. When you're looking at the original, you're just literally looking for the flat spots where the slope is 0. So, there's flat, and there's flat. Those are all my spots where my tangent line would be flat, so that's where the slope is 0. So we would literally just write x equals -4, or we'd say at x equals -4, at x equals 1, and at x equals 6. Those would be my 3 answers for when the slope is 0. So when is the rate of change positive, or when is the slope positive? Well, this is kind of like you've already got your, when you do your extreme value thing, you set up your number line. Well, it's kind of like that. You don't have to actually write it. Might make more sense. Here's what you're actually doing when you do those number lines. Like when you're doing your extreme value ones, you always figure out where the slope is 0. So in that case, it'd be -4, 1, and 6. And then when you're plugging in numbers to your derivative, you figured out the values of the slope. Well, graphically, if you're just looking at a graph, the slope is 0 here, so to the left of 0, what is the slope of that? Well, hey, it's always positive. If we had a function, you could plug in an x value over here, you would get a positive slope. between these, if you plug in a value, hey, look at Remember, you're not looking at the value of the function. You're not looking, oh, here, up here it's positive, down here is negative. You're not looking at the values of the y's. You're looking at the values of the slope. Well, if you do your little pencil thing, this starts flat, and then it goes negative, 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 and it's always negative, the slope. No matter where you would draw a tangent line along that thing, it's always pointing down. So the slope in there is negative. It should be easy to see. The slope between this one and this one is positive, and then the slope goes negative again. Well, so if we just do that, we've now answered both of these. So where is the derivative greater than 0? Well, that would be over here from negative infinity. Sorry, it's hard to do this. Used to my iPad. From negative infinity to negative 4, and from 1 to 6. And then, of course, negative would be negative 4 to 1, and 6 to infinity. Okay, second derivative might be a little harder. So now we're doing, where is the second derivative equal to 0? Where's the second derivative positive, and where's the second derivative negative? To start with on this one, you might want to think about these first, actually, because you should know what these have some meaning, right? If the second derivative is positive, it's concave up. If the second derivative is negative, it's concave down. So going up here now, erase my. Remember, I'm not looking at derivative anymore. I'm still looking at the original function, but I'm not thinking in terms of the derivative or the slopes. I'm thinking in terms of concavity. So where's this thing concave up, and where's it concave down, and where does it change? So if you do your little pencil thing here, if you start from the left, its tangent's pretty big, but it's getting smaller. So when the slope, the change of the slope is getting smaller and smaller and smaller, that's concave down, right? And it's still concave down, and then right, my picture's kind of hard to tell, but right in here somewhere, all of a sudden we're going to stop getting, look, my pencil's pointing way up, it's really steep, so my slope is getting smaller, 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 it's flat, slope's getting negative, but it's still getting smaller, and at some point, we're going to turn around, and right in here somewhere, we're going to flip, and you're going to have to start coming back this way. Alright, so if you think about tangent lines, this would be pretty steep down, but at some point you got to flip, and all of a sudden the slopes are going to start to become more, I don't want to say more positive, but start to become bigger. So it's going to, like, this is very big and negative, and it's going to become less negative, so it's going to get bigger. So we'll say it's right in there somewhere. Should be like right in the middle of that. So that'll be concave down right there, and then that'll be concave up now, because my slopes are getting bigger and bigger and bigger and bigger, and they're still getting bigger, and I'm following along, and now I'm down here, slope is 0, but it's still getting bigger and bigger and bigger and bigger, and then same thing happens over here. At some point I stop getting bigger and bigger and bigger, and I start getting smaller and smaller and smaller, so I can go over that hill. And it should be, again, it's hard to tell in my drawing, and that's even why on the problem it says estimate. So then we start getting smaller and smaller and smaller and smaller, and it's just going to continue to get smaller and smaller and smaller. So, coming down here, those points where concavity changes, so it changed from concave down to concave up, that's where your second derivative will be 0. So we'll say x equals, I don't know, whatever that is, negative 1.8, and x equals, I don't know, 3.8, or 3.5, or whatever, who cares? Something like that. And then, of course, the intervals. So now, when is the second derivative greater than 0? That's concave up, so that'd be in between those. So negative 1.8 to 3.8. Oops, I should. And then less than 0, you'd do these two intervals from here to here and here to here. You know how to write intervals. Negative infinity to negative 1.8 and 3.8 to infinity. that would be concave down. So that's the first one. That's the first kind of problem. It's pretty easy because you're just you're looking at the original function and doing this. The second one though, everything changes. Okay, the second one, everything changes. Like I just said, I had to pause it so I could erase some stuff. Now, for my example, I'm just going to use the same graph, but now you have to completely ignore what we just did on the first one. Now this is the graph of the derivative. So this is f prime. And the question asked to figure out where is the original graph increasing, where is the original decreasing, and where would our extrema be. So all three of these questions are about the original function, and we're looking at the graph of the derivative. So remember, when you're looking at the graph of the derivative, like if I pick a point, like right here, let's say I pick that point, 5, 1. Remember, that 5, 1 is not like a point on the original graph. If this is the graph of the derivative, this means when x is 5, on my original graph, on my original function, whatever it looks like, the slope will be 1. So remember, these are the values of the slopes along the y-axis when you're looking at f prime. So we're looking at the values of the slopes, and we're thinking about the original one. So where would the original be increasing? Well, if the original is increasing, what do we know about the slope of the original? Increasing means going up, right? So it means a positive slope. So where would the original have a positive slope? Ooh, hey, look it, we have a graph of all the slopes. So therefore, it's just whenever this thing is positive, right? These are all positive slopes up here. Remember, even this, even though it's coming down, that just means the second derivative would be negative. Everything between here and here is positive, so that's where your original would be increasing. Those are all positive slope values. Look at the y-axis, they're all positive values. This would be decreasing down here, they're all negative values. So between here and here, you got all positive values. So it's a little bit different way of thinking. So f is increasing from, let's see, I didn't put a point out here, we'll call that -8. That doesn't look like negative, whatever, who cares. -8 to -2 would be increasing because that's where they're all positive, right? The values of the slope, that's what these are, they're all positive, so my original would be increasing from -8 to -2 and from 4 to 8. Or is it decreasing? Well, that's negative slope. Right? Decreasing means going down. So my original, where does it have a negative slope? Oh, come up here. Hey, the slope is negative right here. The slope is negative down here. And the slope's negative out here. Alright, remember, these are just the value. All these y values are values of the slopes. Can't say that enough. So negative infinity to -8. Right, you can write these out. I'm not gonna. I guess I will. -2 to 4. And 8 to infinity. That would be where it's decreasing. And then extrema. Remember those happen where the slope is 0 or where the slope doesn't exist, because we could have corners or we could have a place where the slope goes vertical. So those, or that's right, or endpoints. Those are the three places that happens. We've said that a million times also. This function doesn't have endpoints, obviously. There's arrows, it goes on forever. The slopes go on forever anyway, so the original probably does. The slope looks like it exists everywhere. There's no holes in this. There's no corners, there's nothing crazy. So all I'm looking for is where does the slope equal 0. So come up here, and I hope you don't think it's -4, 1, and 6 again. Because remember, this is the graph of the values of the slopes. So now, where your slope is of your original, thinking back to the original graph, if you were to look at it, the slope would be 0 at -8, -2, 4, and 8. So that's where this thing gets 0. So I'm not going to write that. I'm not going to write that down. But you can write x equals -8, x equals -2, 4, and 8. Those are where the x values of where your extrema would probably occur, because there's probably hills or valleys here on your original. Alright, just thinking to the original. Here the slope is 0, so you're going to have a flat spot. And then your slope goes positive. It gets more and more positive, and then less and less positive, and then back to 0. So it's like, I can't draw it. I don't want to bore you too long. Let's just stop there. That'll be Tuesday. That'll be tomorrow. Hopefully that made sense. Oh, so do try numbers. Add these on to your homework. Just 21 and 23. That's it. Those are the easier of those, so hopefully that works. And hopefully I can figure out how to upload this video before this afternoon. I don't know how it's going to work.